Hello, everyone. Welcome to the Wikimedia Research Showcase in December 2020, last research showcase for this year. I'm Martin Gerlach I'm a research scientist at the Wikimedia Foundation. I am the host for today's showcase. Today's theme will revolve around the topic of disinformation and reliability of sources in Wikipedia. We're looking forward to two exciting presentations. We'll start off with Włodzimierz Lewoniewski. He's an assistant professor at Poznań University of Economics and Business in Poland. He will present recent work around multilingual approaches for assessment of content quality and reliability of sources. And in the second part, we have Diego Saez-Trumper. He's a research scientist here at the foundation, and he'll give an overview over some of the ongoing work that we're doing on fighting disinformation in Wikipedia. After each talk, we have around 10 minutes for Q&A. So if you have a question for one of the speakers or both, please put them in the chat or on IRC. My colleague Isaac Johnson will monitor the channels and will relay them during the discussion. Before we start, one quick announcement is that Wiki Workshop is happening in 2021 and that it is open for submission. I think, if I recall correctly, the deadline for submission is January 29. And another announcement before we start with the talk is from Leila, who wants to say some words before starting off with the talks. Go ahead, please.
Thank you so much, Martin. Hi, everyone. My name is Leila Zia. I'm the head of research here at the Wikimedia Foundation. Before the start of the presentations, I wanted to give you some context around the work that we're doing in the research team that we are encouraging within Wikimedia Foundation, but also outside of Wikimedia Foundation within the broader research community. There's a branch of series of projects and sub-programs within what we call improving knowledge integrity on Wikimedia projects. If you're interested to know what else we're doing in this space beyond what you're hearing today, I encourage you to go to research.wikimedia.org and look at improving a knowledge integrity program and look at some of the sub-projects that are happening there. Broadly speaking, we're focusing on the issues around misinformation and disinformation and the verifiability of content. The lens that we are our team coming at this space is, our job is to primarily make sure that we can help the editors, the patrollers do the work that they are already doing in a more efficient and effective way. You hear a little bit more from Diego today about the work that he and his collaborators have been doing over the past 6 to 9 months in the very narrow and important space of disinformation. I also want to say that disinformation particularly is a very cross-cutting program. It touches on many different teams within our organization and also outside of Wikimedia Foundation within the Wikipedia and Wikimedia editor and patroller communities. Within the foundation, while we're talking primarily about the research component today, there are, of course, teams around who focus on trust and safety, the security, the product, the legal aspects of disinformation. And these teams all need to come together and work together. Our team has a mandate to spend more resources in this space. We are hiring for research scientists in this space, and we expect basically to spend more time and resources here. And with this bit of context, I'm looking forward to the conversation and the presentations ahead. Thank you.
And with this, Włodzimierz, the floor is yours.
Thank you very much. Hello, everyone. My name is Włodzimierz Lewoniewski. I am from Poland. So I would like to present you some of our results, which was conducted with my colleagues from the department. So I will speak about quality assessment and reliability of sources. I have a problem. 1 second here. Okay, share the screen. Now you see Wikipedia and now my presentation. Great. So let's begin with languages. So nowadays, world speaks in over 7,000 different languages. About 3,000 languages are endangered. Just 23 languages account for more than half of the world. Wikipedia, as we know, have been created article in over 300 languages. And we can see on this chart on the right side the most spoken languages. And we see that English is the first one, but a lot of speakers are not native, and including myself. So I'm, as I said before, from Polish University, and in my PhD thesis, which I defended a year ago, I considered 5 language version, which I speak well. So it is Belarusian, Polish, English, Russian, and Ukrainian. And in this work, I propose method for comparing and enriching information in multilingual wikis based on the quality of their, based on the analysis of their quality. So based on different languages, we can find which of them give information of better quality, and we can enrich other less developed language version. For example, Belarusian. I can also admit that in Wikipedia there are two Belarusian languages. So this is one of them. So on Wikipedia, information about various subjects can be created independently in each language version. Therefore, each subject can be described differently. And user to compare this information between languages needs to understand those languages. Other problem that information quality depends on the language edition of Wikipedia, because each language can define own rules and standards. And moreover, these standards might change over time. If we speak about sources, we need to say that sources is one of the most important criteria in quality assessment of Wikipedia articles. So this reliability depends on language version also. And this assessment can be changed over the time. So our team in last years focused on quality assessment of Wikipedia articles and also sources in Wikipedia. One of the problem is a different quality classes, different grading schemas in each language version. Here we have Belarusian, German, English, French, Polish, Russian, and Ukrainian, and we can see how much quality classes are used in each of these language version. So we can see different names, and moreover, even the same name can have different assessment rules in each of the languages. Additional problem is a big number of unassessed articles in Wikipedia. Assessment of the quality of the articles and particular elements in those articles can be done using measures which are related to different quality dimensions. In one hand, Wikipedia is a encyclopedia, so we need to take into the account the quality dimensions which are related to encyclopedias, and also we need to take technology Web 2.0 which are used in Wikipedia to create the content. So we can defined 7 quality dimensions: style, completeness, timeliness, objectivity, credibility, relevance, and readability. 6 years ago, we published a paper which shows that depending on the language, we can have different quality models. So based on machine learning algorithms, we can find which of the measures are most important in quality assessment. For example, one of the most important measures is number of the references, length of the text, number of the images. This is a figure from my PhD thesis, and I compared here 2 languages, English and Russian. And I used also different quality models, binary and nominal. So this figure shows that even depending on a model, we can have different important measures. We can say that some of the measures have showed high prediction assessment, and this figure shows a distribution of the measures in each quality class of English Wikipedia. So the higher value we have, the bigger probability that we will have a lot of articles with higher quality. So we have here length, references, images, headers, and so-called references density. So in our works, we use and we provide synthetic quality measure, which can calculate the quality of Wikipedia article in the scale from 0 to 100 in continuous scale. So we use normalization of each of the important measure and take into the account this rule. So if value of the given feature in the given language exceed the threshold of the median value of the best articles, so it can be set to 100. Otherwise, we will scale this value in relation to the value of this median. This quality score was implemented in WikiRank project. So you can try it and see how it works. And now we're going to one of the important elements of the article's references. Our recent study shows that Wikipedia has over 200 million of references. Of course, English version is most developed, therefore it has the biggest number of the references. Here we can see also the number of unique references. And we need also take into the account that this scale is logarithmic. In this work, we use 2 approaches. First is a simple extraction. A second is a complex extraction. In this complex extraction, we take into the account templates in source code of the article, which have references. So they are not provided directly in the source code, but we need to go to this template to find these references. So you see one line of the code produce this big table, which have different references. So we use in our complex extraction, we include this in analysis. So we count those references. In these references, we can find different citation templates. These templates can describe references by different parameters. For example, author, publication date, publisher, and so on. So we can find what are the most popular templates in references. We can see some of the well-known site journal, site web, site book, and so on. From these templates, we can extract information about most important or popular publishers. So figure at the bottom shows the most frequently used publishers in such citation templates. Based on these citation templates, we can also find which of the references use special identifiers, such as DOI number, ISBN, ESSN, MIT, PMC, and so on. Here we can see how much or what part of the references use these special identifiers. As we see, almost 9% in German language or in English version use ISBN number. Yes, we can also see here unique references with such number. In this paper, we provide popularity and reliability models. So we propose 10 models which use one of the most important measures in quality assessment. So first model is often used in recent work is the frequency model. So we only count how often such references with certain URL address we can met in articles in whole language, across all languages. In P model, we use page view statistics of the article, and next models with P at the beginning use also page views, but in different combination with other measures. For example, PR model use also numbers of the references in the article. So we divide popularity of whole article to number of the references, which use specific URL address. PL model uses length of the article. So we can say that if article is small, these references we can see almost at the beginning, yes. We can change this measure, popularity measure, to other popularity measure, which is median of page views, and have some other results. We can also use number of authors as one of the important measures in such models. So we can have A model, AR model, and AL model. Here we can see the most popular publishers in English Wikipedia, which are provided in citation templates. But we measure not only frequency, it's a F model, but also value of the points and position in rankings according to these other models. And we can see that, for instance, CNN, in frequency model, we have position 22nd. But if we use popularity model, CNN will be at the second place in such ranking. And so on. We can see that place can be different depending on the model. Okay. Such models were used to create individual profiles of the sources, and it was implemented in Bestref project. So we can choose some domain name, host name, and check what is the position of the source in each language version of Wikipedia. Depending on the language, we can expect different position in the rankings. So here we take as an example New York Times, Spiegel, Le Monde, and El País. If we considered New York Times, we see that based on frequency model, in all languages, we have this source at the 7th place. But if we count the reliability and popularity of the source, according to peer model, we will have 3rd place. And also we can see that each language version can have own, we can say, opinion about reliability or popularity of the source. So we can expect that German source, spiegel.de, will be the most reliable and popular among other languages. The same is to lemonde.fr, and Spanish source El País. There is special extension for browsers that can be used to assess the sources and quality of articles. Some of them are presented in this slide. Maybe I can show quickly how it works. So when we have some articles, so I opened article about Poznań in Polish Wikipedia, and when we have some source, for example, we can open here, we can find some such button, which is Bestref extension, and we can see that each of the position will enriched by information about position of the source in local and global ranking. So, for example, StatGov.pl, it is statistical office in Poland. It has global rank and local rank. So in Polish Wikipedia, it is on 1st place. In global ranking, is 289th. We can go to this profile and find other information about reliability and popularity of this source. We can also find here link to analysis of overview of this article, analysis of different hosts and values position in rankings, global and local. It is one of the examples that we can also use these models to calculate the reliability and popularity and share this data with society. So you can use this data as you wish. So this and other models can help to enrich various language versions of Wikipedia and other knowledge bases with information of better quality. In one hand, we can compare the information between different language versions of Wikipedia and say which language is better and use it to enrich other language version, but we can also, based on analysis of the references, find the most important source and use it to enrich Wikipedia, Wikidata, and so on. Here we have an example of project which is called GFS, which compare information between language versions of Wikipedia, and not only, also it is used other sources to enrich Wikidata. So we plan in future implement some of the modules in this service. So that's all. I try to be to have short explanation about what we done. If you have some question, feel free to ask. Thank you very much.
Thanks so much, Włodzimierz, for your presentation. Perfectly on time. We have plenty of time for questions. If I'll pass it to the room here, if anyone wants to jump in.
Yeah, I have one question, Martin.
Go for it, Diego.
Well, super interesting work. Thank you very much. It's really interesting. I want to ask you if you can elaborate a bit on the limitations of having this single dimension ranking. So you said, for example, statistics in the official statistic page in Polish is the fourth site for reference in Polish, but I can imagine that depending which topic you are covering, for example, it would be more important or less important. So which things you think could be improved, or which other, if you will build a multidimensional ranking, which other dimensions you would like to consider?
Thanks, Diego. That's true. You mentioned about topics because stat committee often used to provide data, statistical data about, for example, cities. So we can expect that if we will analyze only Polish cities, it will be at the first place. So I think, as you mentioned, if we can provide some new measures, and of course, we need to improve such models. It's not perfect approach, I agree. But we can say it is a beginning, and we have a lot of things to do. And one of the measures, it can be assessment of the topic in which this source was placed. Another thing, that place in which this topic was inserted, in which this source was inserted. For example, maybe it's info box, and we can analyze that this source related to popularity statistics, yes, or it is some chemical info box, and it shows some reference to some chemical data, and so on. So I agree, one of the things that we can improve is topics. Second thing is the place where it's placed. Maybe if it is closer to the top of the page is more important than in the bottom, because you can expect that things that are placed on the top are people read often, more often than something that is on the bottom. Especially it is applicable to info boxes. So this info boxes is very useful to check some important facts about subjects. So there is a lot of interesting measures that we can add. For example, in my PhD thesis, I used over 150 different measures related to quality and popularity of article and info box. So there is a lot of work to do. And 150, it's not a limit. There is a lot of possibilities, especially as we considered the technologies. Yes, so we have a lot of data. Wikimedia research provides new data, for example, clickstream data. Yes, so we can work on it.
Great. I hear we have many questions in IRC and on YouTube. Isaac.
Yeah, so we got a couple, so I'll just start going through them. The first one comes from YouTube. And it's the question is it possible to assess the reliability of sources in less developed languages, so the smaller Wikipedias? Just love to hear your comment on that.
Okay, so of course, if you have a lot of data, it is we can say more possible to create some good model. You know, in machine learning algorithms, the more data you have, the better model it will be. Often, not always, but often. So it is possible to create for less developed languages such models, and it is even now works. You can check this site bestref.net, because in our research we use only 55 languages, but it is applicable to even less developed languages which have 1,000 articles.
Great, thank you. The next question is also from YouTube, and it's about the external references piece. And the comment was, I suspect Oxford Exile are represented as common publishers because that parameter is commonly used in Citebook, so one of the citation templates. But people tend to skip it for CiteWeb and CiteJournal, so these other templates. And the question was, are you pulling the source publisher information from all possible fields used across the different citation templates? And I think I would also add to this, like, how do you deal with these varying kind of norms and how the templates are used and things like that?
Yes, I agree, Isaac. It's a problem because sometimes you have citation templates which not have information about direct URL address. For example, if you cite some encyclopedia, you can use only number of the article or position and that's all. So from source code of this article, it is difficult to find what is the domain, yes, what is the source URL address. And of course, when I show this in my presentation, this figure, this word cloud, we use only parameter publisher. We do not take into the account this specific situation when this parameter can be provided automatically, for example. And we write it in our paper about such problems, about such limitation. So therefore, as I said before, we have a lot of work to do. So.
Can I keep going, Martin?
Yeah, keep going.
All right. From IRC, we have a clarification question around source quality, and then kind of a follow-up based upon that. So the clarification is the reliability of a source like CNN or any other source, is it inferred from the quality of articles that cited it? So that's the kind of clarification. And then the follow-on is, have you thought about comparing the measure of source quality to other source reliability rating systems like NewsGuard?
No, we do not. Maybe we can begin from second part of this question. No, we do not compare it, but we plan to do it because we can, for example, compare the result of such models with some scores which give some external catalogs, maybe such as alexa.com, which have information about popularity of the source, or SimilarWeb. It, of course, one of the possibilities, yes, to compare the quality, we can say, of such models, yes. But, you know, there is a problem because popularity doesn't mean the reliability, yes. So it is one of the possible approach, but we must go deeply to understand what are the rules, yes, because Reliability is subjective term, and each language version can define can have own opinion about the same source. Okay.
Great, thank you.
If you have,
oh, yes.
if you have more, Isaac, maybe we
Yes.
can still have. Yeah, let's do 1, 2 more. Yeah.
Okay. This next one, and I apologize if you addressed this in the answer to Diego. I was trying to pull questions together, so just tell me if you did. But the question was, have you examined the quality, popularity, and reliability of articles across languages, split up by, distinguished by categories? So I think split up by like topics for the articles.
Yes, we did it in this article about multilingual ranking. So we divide articles in 27 categories based on millions of categories in articles, and we wanted to know which topic is best described in each of the languages. And we describe it in our paper. So as I said, we have some results. These results can be interesting, but we see also there is a lot of problems, and we can do additional research on it, maybe jointly with Wikimedia research team.
Great. Am I good, Martin?
Yeah. Let's use some more. Let's use 5 more minutes.
There was a general question. So you talked about the quality score in WikiRank, and the individual just wanted to, if you could tell us more about this project, the main features and measurements that you're making there, and whether they can use the data.
Okay, about using data, you feel free to use it. It's even this WikiRank project has an API interface, so we can send requests and get results. WikiRank also measures popularity, citations of the articles among languages, and authors' interests. So we can even find in which months what article was edited with a larger number of the authors. There are also rankings of different topics such as films, video games, cryptocurrencies, firms, and so on. So even as I know, it provides every day's ranking, but not in one language, but comparing other languages. So data are free, open. It's not a problem to use it. And it can be used also to measure quality in other way and compare the languages between each other.
Isaac, are there more questions?
Yeah.
We have 1 more.
This next one is more specific, but I think I'm going to broaden it too. The specific question is, do you plan to increase the number of measures in the reliability model? And I would just broaden that as well to future work. Like, where are you thinking about taking this?
Yes, it was a question from Diego also. So of course, when we do this research, we find a lot of other problems, and which we can cover by providing some new measurements, new rules, and so on. So yes, the answer is yes. There is a lot of potential measures that can be included in such reliability models. We can use such measures which are related to articles, also related to other parts of the article, such as info box, for example. And moreover, we can use external sources to assess the quality of these sources. As I said before, for example, Alexa.com or Alexa Ranking or similar web.
Final question, Isaac, before we move on.
Yeah, the next, there's two questions really, and I think they boil down to like, how can we build some tools around this? But the first one is, would you be interested in using semantic similarity based upon the Wikipedia category graph or Wikidata taxonomy to find relevant references about a statement? For
Of
instance,
course, it's very interesting topic. Moreover, based on such technologies, we can find which sources are more applicable or more relevant to specific portion of data, we can say, or specific fact. For example, popularity of the cities or popularity even of Polish cities. Yeah? So if we take other country, maybe it will be other source as the most reliable source. Of course, it's interesting topic. I invite to contact with me and we can think what we can do.
Great. With that, I think we can wrap up the discussion for now. Thanks, Włodzimierz.
Yes, thank you very much.
You'll stay around. I think maybe we can revisit some of the questions or if there's more coming up to after Diego's talk. But for now, thanks again, and let's switch to Diego's talk. Go ahead. We can see you, but we cannot hear you, Diego. We can see the talk. We can see the slides.
Now you
Yes.
can.
Perfect.
You can hear me and you can see the slides. Okay. Thank you very much. Thank you, Włodzimierz, for the super interesting presentation. We first need to talk later. Also, thank you, Martin, for organizing and coordinating all this last research showcase. You're doing an amazing job, and thank you all for attending today. So what I want to do today is to talk a bit about the challenges that we have on fighting disinformation on Wikipedia, how this is different from other pages, platforms, or communities, and show you some of the things that we have done in the past month, some longer time projects. So basically, I will talk about three things: explain a bit the context, then explain what we have done so far. We started working in this disinformation space 1 year ago, more or less, like 14 months ago, and in the research team, and then telling you a bit about the current and future work, and also mention some data that we are planning to release hopefully soon. So the first thing important about Wikipedia when we talk about disinformation and misinformation is that Wikipedia is currently used as ground truth for many automatic fact-checking tasks. So if you see the typical natural language inference machine learning task, that is basically giving a claim and giving a text, knowing that claim is supported by a text, the text that people is using for like the ground truth is Wikipedia. So this puts a lot of responsibility on us, on the editors especially, but also it's a constraint for us because we don't have such ground truth. We can't directly at least replicate what is done by others. It's also very important to mention that this fact-checking, automatic fact-checking task is nowadays pretty popular in the research community, but this is still under development. And I could say, even if you want to download any of the methods that has been published in the last years, there's nothing that will work out of the box. So so it's very important to have this in mind. And the other important thing when we talk about Wikipedia is that usually when people think about fake news and disinformation, they are thinking in other platforms and communities that are very different from Wikipedia. So, for example, in social networks, the most popular ones, I don't think that they need to mention, they're usually about expressing opinions. And there, the most important thing is popularity. So maybe what some of these big techs are doing with in terms of stopping fake news to spread is to watch a very popular piece of information that are spreading, and try to differentiate what is an opinion there, what is a fact, and then try to fact check the fact that has been expressed. And as I said, popularity is very important. No one will care too much about, I don't know, some fake news that is shared on one of these social networks if it's not retweeted or shared or whatever is the name that they are using in this particular platform. It's also that there's no rules usually in this kind of platforms in terms of the traceability or reliability of the information that you add there, especially because it's very about opinions. So many of the things that you will see as fake news, I was thinking to add some examples, but I don't want to spend and to waste your time showing you news about 5G or flat Earth that people in this kind of platform needs to fight. In Wikipedia, is very different. So Wikipedia is about sharing knowledge. It's not about sharing your opinion. And basically, there's a lot of human effort. Most of the human effort is not centered in have popular content or in have arousal content. Most of the policies and the mechanism side are about content integrity, so content quality, and following a very, I don't know if complex, but a complete process that the community has been developing and the different community has been developing for years to keep information as good as possible. For sure, that doesn't mean that you won't find false information on Wikipedia, but this means that you have a lot of human eyes looking to that information, trying to improve it. So our challenges are very different from what will happen for the big techs when they think in stopping the spread of fake news, or for example in, I don't know, in some phone messaging apps. It's completely different. First of all, we don't have this ground truth that they are using, so we can use Wikipedia. We can use kind of contradictions within Wikipedia, but it's not that you have a claim and you know to which document is that belonging, or at least we have no single ground truth. And this is a complexity because you can say, okay, yeah, our ground truth will be the references that people is adding on Wikipedia. But that means a very heterogeneous kind of document that you will need to read and you will need to compare with. We also have the problem of circular reporting on Wikipedia. That is what this plot is about, this graph is about. So sometimes Wikipedia is not only used for automatic fact checkers, but it's used on the media to justify things. So just knowing that something appears related to Wikipedia on the news media, it doesn't mean that this is necessarily true or that is following the core content policies on Wikipedia. The other problem that you have in Wikipedia is this kind of subtle attacks. So I always mention this, and maybe I need to stop giving ideas to people, but I remember once I was giving a talk about content reliability about Wikipedia, and someone in the audience mentioned it, that people was entering to some physics articles on Wikipedia and changing just a plus for a minus, or these kind of subtle things that would be very difficult to catch for a machine, for example, if you want to use that. Even for a human, if they are not looking all the time. So people can try to add this kind of very subtle attacks that will be very difficult to measure. That's completely different with a very popular news about flat Earth. The other important thing, and Włodzimierz mentioned something about that, is the imbalance that we have across projects. So the kind of problems that you have in very popular projects like the English Wikipedia, it's very different from the problems that you will have in smaller wikis where you have less editors and also less information available on that language to compare with. So you will have a lot of problems in terms of if you want to cross references that are in different languages. This is also a challenge. And maybe related with that is the existence of cultural differences. So we don't have a single ground truth. And you can imagine, for example, an article about a disputed topic between two different cultures or two different countries. I don't want to go in examples there, but you can imagine some topics that if you read or if you want to understand the beliefs or what is considered truth in one country will be very different what is considered true in another country. And I put this example, for example, people is using in English Wikipedia, there's a template to mark articles that are built just on top of US government. So it's this US government point of view. This is considered a kind of a problem in English Wikipedia. So you need to balance all these kind of things. And what I want to say is basically we don't have simple solutions for the disinformation problem in Wikipedia, because the kind of problem that we have are not related with the same problems that the rest of the researchers, communities, companies are working on when they are not specifically thinking about Wikipedia. So what is our approach? What is the thing that we have been done in this last months? So basically, I can summarize this in three main goals that we have. One is about understanding more what is the framework that we can use to work about Wikipedia reliability. So have more conceptual models and also provide insights, understanding how this thing is developing within Wikipedia. And it's not the work that we do within the Wikimedia research group or even in the foundation. It's also trying to gather all the different research that has been done by many researchers around the world, but transforming this in concepts and insights that can be actionable and useful for the community. We also can work in the what we call prevention, that is related with identifying threats. So, for example, identify new methods that people is using to introduce false information in Wikipedia or in other platforms that can be used in Wikipedia, and to generate early warnings about possible problems. To mention an example, how we can use the concept of data voids that has been becoming popular in the last years, where people where people understand that it's easier to manipulate content in areas that you don't have enough information. And finally, and the thing that many people is expecting from us, I think, it's how we can support the workflows of editors. So basically, given that the research team in the Wikimedia Foundation is mainly a computer scientist doing machine learning, what is expected in somehow is that we create machine learning tools that will support the editors. But as I said, this is not easy, because we already have a lot of human eyes looking to the content, and machines are not smarter usually than the experienced or even not experienced editors. So basically, what we want to do here is create models, algorithms, and tools that will help editors to work faster. So basically, doing tasks that could be simple, but they're very time-consuming for a human. So basically, it's improving the efficiency of editors in their task. And the most complex thing that we are working on is how we can use machine learning to identify potential content policy violations. That it's related with the first thing. It's difficult that the machine will have an accuracy finding this information better than a subject expert on a topic. But at least we can help them to narrow down the amount of documents, articles, edits that they need to look at. So basically, this is the final goal. So about the first thing, we started, and this is like the kickstart of this research. We started last year in 2019. writing this white paper, let's call it, about online disinformation, trying to get this framework that I was mentioning before. If you want to know more about this work, I will mention few insights of that. But if you want to search, this is available on archive, and you can download it to have more details. But the first thing that we needed was to understand a kind of a taxonomy of what is the different kind of information and what we will interpret as disinformation, reading different authors and trying to expand the available taxonomies that were out there to our needs. And basically, there are two things that are important when we are talking about taxonomy of disinformation. That one is about the authenticity, but the other is about the intention. So it's not the same that you introduce false information with the intention of deceive or to trick people, that if you are just adding false information because you don't know if that's true or not. And where machines can be very good, or at least can do something, I don't know if they can be very good trying to assess the authenticity following some of the policies that already exist on the Wikipedia editors community. The intention is very, very difficult to judge. So what we could try to do, or what we are trying to do, is to work more in the authenticity a bit and let them editors to judge this kind of intention bit that is much more difficult for a machine. The other thing that I already mentioned is trying to understand what are the main vulnerabilities of Wikipedia. And this is a proposal, so this I will be happy to hear comments on this table. We have this information on Meta and on the paper that I already mentioned about which are the most important threats in terms of vulnerabilities that the Wikipedia can have for disinformation. And as I mentioned, here is very different from what is happening in other platforms. So in other platforms, for example, bots are a threat that is very well known, because given that most of the social networks are about popularity, if you can have these bots artificially increasing the popularity, this kind of astroturfing, for example, technique, this can be very important. But in Wikipedia, this is maybe not the most important thing. There are higher problems that you won't have in other platforms, like circular reporting that I already mentioned. So people that introduce some content on Wikipedia use that to refer from a, let's call it, reputable news or information source, and then citing that news source, that information source on Wikipedia. I will mention anecdotal examples, but there's some reports when sport news wants to say that one football player has been transferred to a team, they put that information on Wikipedia, then they go to their news site and said Wikipedia is saying that this person was transferred to that team, and then on Wikipedia they can cite their news source to support that claim. So this is a naive example. You can imagine much more complex problems there. I won't stop on this. I have already presented some of this work before, but one of the things that I want to mention is that, and to emphasize and highlight, is that the kind of threats, vulnerabilities that we have are very different from other platforms. So in terms of generating tools and generating awareness, one of the things that we worked during the last year, and this work was led by Jonathan Morgan, that is not already, he left the team, but thank you, Jonathan, for this great work and for all the other great work, and also by Isaac, that is today in this call, was to generate this social media traffic report. This was a request that we got from the community in Wikimedia 2019, if I'm not wrong. That was basically, people was trying to understand, editors were very interested in understanding when a page was receiving a lot of visits, a lot of activity from social media. And there are different reasons why this can happen. For example, this is the report for yesterday, I think it's that, yeah. So maybe now that YouTube is using many times the links to Wikipedia when they want to explain something about a source, for example, here it's BBC, you have the link there, and people just might be clicking on those links because they want to learn more about BBC. But can be also the case that in some social networks, they use their accounts to program attacks to some page, or that they create some kind of vandalism that they try to increase their impact, sharing that in social media. So we can go to these very basic tools, but very powerful ones, to very much more abstract or complex. I don't know if complex is the word, but abstract projects that we are working on, trying to understand what is the how content propagate within projects. So as I mentioned, there are different needs depending on the nature or the size of the projects, basically. So it's the needs in English Wikipedia will be different from the ones in Catalan, for example. And one of the things that we want to understand is if we can predict what is the likelihood of one piece of content to travel from one Wikipedia to other Wikipedia. So we are developing a model in collaboration with researchers in Brazil and in Telefónica Research in Barcelona to create a model that will predict the likelihood of a piece of content that was seeded in one project to travel to other projects. And this has many different applications, like understanding how good content propagates, and if we have some annotation of bad content, we can use this as a kind of outlier detection problem, but also give insights to understand if someone wants to introduce some disinformation or bad content in one project, how likely is that if you can introduce this disinformation in projects that doesn't have enough editors to check all the content, how likely is this to make it to the big projects? And we found some numbers there. This is an ongoing work that we are still doing with these collaborators. But if you want to know more about the project, you have the link. All the experiments are now reported on Meta. There you have the link. And basically, what we have seen is that most of the content travels from small projects to other small projects, and that's kind of worrying in the sense of that there's maybe a lot of content that is traveling from project to project without a lot of editors looking to that piece of content. Another thing that we are working, and this is with collaborators in Asia, so from KAIST in South Korea and also from Taiwan and Hong Kong, we have been working in using data that is within our projects to compare with other data that is in our projects. And the first approach, the first try that we did there was trying to align content that is on Wikipedia, on Wikidata. You also can see the first round of analysis in Meta. You have also the link there. But basically, this is a typical natural language inference task or textual entitlement task, where we want to get a claim. Let's say that the claim is the claim coming from Wikidata, that we can transform easily to many different languages, given the language agnostic approach used by Wikidata. So we want to compare those claims with the document that will support that claim, that will be the sentence that are in articles in a specific language. And here, where I was mentioning that the state-of-art models for doing this kind of task are still growing, and are still, I think they need a lot of improvement. And I'm not just talking about our model that you can see, you can check what is the accuracy that we're having now, and this will depend in the type of claim that you are comparing with. but you can compare also what is in the literature. There's a lot of shared tasks, contests that people is doing in the research community, and still you will see that the accuracy of the best models are usually around the 60%. In tasks similar with that will be around 60%, 70% in the best cases. So this is one line of research that we are developing too. And the main piece of work that we are working now is about templates. So templates are transclusions of content on Wikipedia. I think many of the audience here will know about this, but they can be used for many different things. In Włodzimir's presentation, he was mentioning templates that are related with citations, but there's a bunch of templates that are also used to signal problems with content reliability. And all this idea came from this work that was done before we started working on this disinformation bit, but is, I would say, at least for me, the main inspiration that I'm following now, and was a work led by Miriam Reddy that is still part of our team. And in fact, I'm working in collaboration with her and with she in this project. And basically, what they developed, I think 2 years ago, was this natural language processing algorithm that was able to find statements on Wikipedia that were that needs a citation. So basically, unsourced content on Wikipedia. So what they show is that with the enough data and enough annotations, you can create an algorithm that is able to scan an article, split it in sentences, and find which sentences will require or might require a citation. And this is basically finding the citation needed template. So the idea that we are working on now, it's about generating other data sets with other templates. And this is the project that we are currently working on. We have now identified 41 templates related with content reliability. We took an initial list of categories where we extract these templates from the Wiki project reliability, and we find, as I mentioned, 41 different templates. And the interesting thing is that looking to the history of revisions, so the different versions of articles, we can find positive and negative examples. We're working now with an outreach. That outreach is an internship program, an international internship program, to build this data set that we want to release soon. So and basically the goal of this presentation is to ask you to provide feedback on this list. As I said, we manually create this list based on the templates that we found there. But I would love to have more feedback. So if you can visit this meta page that is under my user in meta.wikimedia.org and provide some feedback. I especially encourage editors to go and check if these templates make sense to you, if you think that some of them needs to be removed, and especially if you think that there's some templates missing. Please go to that page, or you can just go to my user page, and then you will find the link to this list. And please provide feedback there, because what we want to do is create big enough data sets and with high quality, because we know, or with our hypothesis, more than we know, our hypothesis is that the accuracy of these templates is it's very good. So basically, people adding this kind of templates, they are usually expert editors on Wikipedia, although in the first analysis we have already found that there's some mistakes or some problems in terms of accuracy, but still it's high quality tag by experts, and but the recall might be not very good. So That means that if you find that template means that, for example, the article is self-contradictory, but it doesn't mean that all self-contradictory articles have this template. And in fact, this is exactly what we want to help to solve with these machine learning approaches. So we are developing this methodology to generate a good positive and negative examples. And this is exactly what we want to ask your feedback for. Because people is relying a lot, and I'm almost finishing, people is relying a lot in the media when you see talks from different companies talking about disinformation and how artificial intelligence can help us to fight against disinformation. And now disinformation is kind of the new keyword that people use when they want to get some funding. But artificial intelligence is still very far from being able to be better in assessing problems with content than humans. I always, this is my favorite slide when I talk about artificial intelligence or machine learning. So there's this idea of this brilliant artificial intelligence that could destroy the world or that can save us from everything. But the way that we have to differentiate machines from humans is ask them to do tasks that any human can do, and that will be very difficult for machines. So, and the interesting thing here is that it's not that machines are, I usually put here that the name of this slide is stupid machines. I removed that to have the correct language in this presentation. But someone working in image recognition can say, no, this is very easy to beat if you image processing algorithm can recognize bicycles if you train with the right data. And this is exactly what we want to do. We don't want to create, or we don't have the capacity to create an algorithm in-house for each of these 41 different templates that we have found. And I'm mentioning just the example in English. We're extending this to other languages too. So basically, our plan now is to release these data sets and to ask the community, especially people that is working in natural language processing, to work with this data. Usually these NLP systems requires a lot of processing power, a lot of GPUs and pre-trained models. As I mentioned, there's no model now that you can just go and download for this natural language inference and apply in your problem. So basically, what we will be doing in the next 6 months would be to release a set of new data sets related with content reliability, following this templates approach. We have been already working in some of base models for one of these templates, and let the community to try to improve these models as much as possible. The other thing that we are doing, and I want to use this presentation to talk about that, is we have this worldwide internship program. So basically, we are hiring interns from different parts of the world. Specifically in the disinformation bit, we have already the pleasure to work with the EU from the National Cheng Kung University from Taiwan, with Rodolfo Valentin from the Universidade Federal de Espírito Santo in Brazil, and currently we're working with Kay Wong from Malaysia, that she's working with us from this outreach program that is also an amazing program for interns. So if you're interested or you have students that are interested in doing an internship with us, we are looking especially for skills, people with skills in NLP, and also hopefully both things together, people that can help us to build some front-end interfaces to serve these models to create a proof of concept, for example, and work with editors on this space. So again, if you are interested also in the internship program, or and especially in providing some feedback about the templates, please contact me on that email, and I'll be super happy to answer and to get and to process your feedback. So thank you very much, and that was all for today from my side.
Thank you, Diego, for this talk. I'll first ask in the room if anyone wants to get of a question. Otherwise, if that's not the case, I think there's something from YouTube or from IRC.
Yep. First question comes from IRC, and it's about kind of the understand side of this work, Diego, and about the content creation dynamics on social media versus Wikipedia. The person was wondering whether game theory, so like understanding kind of users' motivations and the rewards of contributing to social media versus Wikipedia, whether that would be useful for better understanding the dynamics of disinformation on these different platforms.
It sounds like a cool idea. I haven't thought about that. I would need to think how we will define the players, which will be the Nash equilibrium here. But yeah, I'll be happy to discuss more about if the person that is asking this question have some more specific proposal. It sounds interesting. I cannot directly think now how this will work, but I'll be happy to hear more about that. So please send me an email or contact me in IRC.
Cool. I'll pass on. Maybe in the same vein, this wasn't really a discussion, but there was a question. There was a discussion about cytogenesis, which is something you brought up, and I wonder if you have thoughts on kind of better studying cytogenesis and how you'd approach that.
Yeah, the cytogenesis thing is one of the most interesting bits here, and I think would be very interesting also to hear Włodzimierz's thoughts about this, because this is related with citations. So basically what we can do here is to try to build a temporal series, and I've been exploring this very high level, but basically we could build some time series or more than a time series, a sequence where the citation is added on the news, and then when some keyword is added on the article, and try to model how this process usually works. For example, one thing that we could do is, given the list of external links that we have on Wikipedia, go try to download the information there, see which of them usually mention Wikipedia, because there's also some style or content policies on the news sources. Some of them use Wikipedia as a source, others don't. It would be the first thing to narrow down the problem will be to check which of the, let's say, relevant sources that we see in Wikipedia are using Wikipedia as a source, and narrowing down to those sites, we could try to understand how is this flow. So where the mention of the keyword appears first, and try to find how often this happens. I don't have numbers for this. The exercise that I have done is to ask the community of editors in few countries, and I have anecdotal evidence that this is happening more usually than we think, but I don't know until which extent. So the first thing will be to measure how big is this problem.
Great. Am I good to continue, Martin?
Yeah. If there's more, let's keep going here.
Yeah, this first question actually came before Diego's presentation for Włodzimierz, but I would also, if Diego has thoughts on it, I would love to hear thoughts too. And it's about the relationship between reliability of sources and popularity on Wikipedia. And the example that was given was the Daily Mail, which was used as a source many, many, many times. And then at a certain point, it was decided, hey, this is no longer a reliable source. And so I'm interested in your thoughts around kind of that tension between popularity and reliability.
So I must to answer, yes? Okay.
Go ahead.
So it's an interesting question. Popular doesn't mean reliable. So if you go to such services as AlexaRank and find which services are most popular, Facebook, for example, yes, doesn't mean that it's reliable sources. But if you go to some official fan page, we can say that it is reliable. So there is some organization which is on the contact. You can check, contact them and ask if it's true or not, and so on. So in our paper, we try to find a relation between results which are give each of this model, and find there is sometimes even big differences between model which are based on popularity score or based on number of the authors in article. So generally, we can say it works. When source is popular, it usually means that it is reliable because it's accepted by Wikipedian community. So, if somebody will put source which is not reliable, somebody of the editors can find it and delete it or change it to other source. So we use also this potential of collaborating, yes, between such users, and society decides, yes, if the source is proper or not, if it's reliable or not. So if it is put it on popular article, it means that a lot of people read this article, and if there is a problem with reliability of the source, it will be quickly identified, and somebody will change it, delete it, and so on. But it's not a rule. So popularity doesn't mean reliability. But also the question is, who is assessing this quality or popularity or quality or reliability? Because this example of Daily Mail, maybe in one language it is accepted as very reliable source, but in other language, maybe today it's not a good source. Example also with countries which have some conflicts between each other. Before conflict, some of the sources was reliable, but when comes this conflict, this source in some language now is not reliable. Yes, so it can be also changed during the time.
Just to add something on top of Włodzimierz reflection, I think there are two important aspects. One is considering the dynamics, so the reliability or how trustable is a source is dynamic. It can change in time, and you can think for different ways that it change in policy, change in owners, change in the government if it's a state-owned media. But the other thing it's very important is that, in my opinion, any ranking, and there's some discussion in the community of creating this or not, it should be multidimensional. So it's very difficult to come up with just one number. So you can do it for, it's a good starting point, but I think if you want to use something that will be adopted by the community, maybe we need to provide several dimensions where users can look to. I think this is very important for editors, that could be that they can use that information when they add sources. This is more difficult for readers. We have done also some collaborations with Margie and people in CMU, Margie in the design research team, trying to understand how people interpret problems or some banners with problems in content. And people really doesn't look that much to this kind of warnings, but at least if we can provide good information to editors with these multidimensional scores, they can use the right score for, or the right reference for a given piece of content. And this is also dynamic in terms of there's some sources that are very good when you are working with breaking news. For example, I don't know, if you think about COVID, maybe the first information will be in some newspaper, but quickly you need to move that to some journals that are doing studies or trying to find the secondary source that has been citing this work. So it's a very complex problem, and this is one of the things that I was mentioning, why this is, in our case, is very different from social media, because the lifespan of a piece of content on social media is very short. Like the trending topic from today is old tomorrow. In the case of Wikipedia, the content stays there forever and can be accessed many times later. So thinking that we'll have forever score on the reliability of some piece of information and in the source, I think it's not real. We need to have a dynamic process where we help the editors to keep sources as most reliable possible and as most updated as possible.
Great, thank you so much. I think with this we're at time, almost at the hour, and great to see such a lively discussion. That was really interesting. Thanks for everyone who joined and for your questions to us. This is really great to have this interactive discussion. Thanks for the speakers to take the time to present here. Really interesting, Włodzimierz and Diego. Thanks to Isaac for getting the questions in. For the tech support and organization support, Jana and Emerald. I hope I see you at the next showcase in the next year in January. One reminder, final reminder again about the Wiki Workshop. We are happy to see your submissions there. Miriam reminded me who's putting the things together there. It's open, it will take place next year. Deadline, January 29th. Send us your papers about Wiki, everything related to Wikipedia, Wikidata, Wikimedia. Thanks so much. Have a great rest of the day and a good start for the next year. Bye, everyone.